for apparatus and material, we have heat transfer service unit, linear heat conduction unit, and radial heat conduction unit. Also, we have water supply, and we have three specimens: brass, stainless steel, and aluminium.
To start the experiment, we need to plug in the thermocouples into the thermocouple socket according to its level.
Next, put the material inside the linear heat conduction unit and make sure to lock and screw it tightly. Before we start our experiment, we have to make sure that the water is flowing into the linear heat conduction unit so that it can prevent any overheating occurs. Okay, so firstly, to using this machine with H112 heat transfer service unit, we turn on the power supply and then turn on the main switch. After that, we tap the voltage controller into 100 volt. Uh, 100 volt and record the value of current. After that, we record the value of temperature for each thermocouple socket. So for this linear heat conduction, we are using T1, T2, T3, T6, T7, and T8. Okay.
For our second reading, we increase the voltage into 140 volts. So after we increase the voltage, we record the currents and the temperature for each of the thermocouple sockets. And then for our last reading, which will be the third reading, we increase another 40 voltage, which will make it as 180 volts. And we read again the currents and the temperature of each thermocouple sockets.
After we finish the first material, repeat the process by replacing the settle with aluminium and brass. For the radial heat conduction experiment, we have to repeat the same procedure as linear heat conduction. But in this experiment, we only use one specimen, which is brass material. And then we have to connect this thermocouple according to the label on this table, which is T1 to T6 only.
Okay, so for this experiment, there are three variables, which is manipulative variables, control variables, and dependent variables. Okay, for the manipulative variables, the manipulative variable is the voltage that we choose, which is the 100 voltage, 140 voltage, and 180 voltage. For the control variables, there's a material type, which is a brass linear, brass radial, stainless steel, and aluminium. Then the next control variable is the channel number. Then for the dependent variables, the dependent variable for this experiment is the temperature on each channel that we recorded during the experiment.
In the experiment, we expect the linear heat transfer setup to show a steeper temperature gradient compared to the radial setup. This is because in linear conduction, heat flows directly through a solid rod in one dimension, resulting in faster and more efficient heat transfer. In contrast, radial heat transfer occurs outward through a cylindrical shape, causing the heat to spread over a larger area and reducing the overall transfer rate. Therefore, the temperature drop in radial conduction is expected to be more gradual. We compare the same material, which is brass, in both configurations. The linear arrangement should yield a higher calculated heat transfer rate and thermal conductivity than the radial one. The differences will be analyzed using Fourier's law, allowing us to compare experiment values with theoretical expectation and evaluate the effect of geometry and heat flow efficiency.
The safety measure of this experiment is to always use closed shoes in the lab and make sure the apparatus is in good condition and make sure the apparatus is not turned on before installing the specimen.